Let's look at number 14. What we're told is the organization can choose a president and a vice president. Okay. They can choose this 56 ways. So we know that if we multiply this number, and this number together, we're going to get 56. And we want to know how many members are in the organization. Well, let's see. We don't know how many. Let's call it N. There's N number of people in this organization. So how many people do we have to choose from for president? Well, that would be N. And then how many for vice president? That would be 1 less, N minus 1. So what we know is that N times N minus 1 is 56. A little bit of algebra here. So how about N squared minus N equals 56? Let's subtract the 56. N squared minus N minus 56 equals 0. It's quadratic, so we'll try factoring here. Something equals 0. So how about N and N? I'm thinking 7 and 8. 7 and 8, but it's going to be positive 7, negative 8. So N is equal to negative 7, positive 8. But N is the number of members in this organization. Can't be negative. So I'm going to claim that there are 8 people in this organization. Number 15 tells us that, asks us how many ways can 10 books be arranged on a shelf such that a particular pair will be next to each other. All right, so let's draw this, see what we come up with here. So we've got 10 books. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's our 10 books, and we want a particular pair to be next to each other. So where can that pair be? That pair could be here, 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 these two, these two, these two, these two, or these two. Let's see, what have we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9. That means that there's 9 ways to place those books, those pairs. Take a pair of books, there's 9 positions we can put them. We take a pair of books, we can put them in the first 2, 2 and 3, 3 and 4. Then the second decision we have to make is, okay, we've got 2 books, column A and B. Which order do you want? How do you arrange them? A and B or B and A? Well, there's 2 ways to make that decision. Then there was 10 books altogether. We've placed 2, so there's 8 left, and there's 8 factorial ways to arrange those books. There's the answer. Let's compute it out. I computed that, and I got 725,760. Now in 16, here's what we have. All right, so I'll put these in a room here. We've got 8 women, 6 men. So altogether, N is equal to 14. And a committee of 3 men and 3 women is to be formed. So we want to know how many ways can we do that, given that, what do we have here? 1 man and 1 woman refuse to serve together. Here's how this, I think, could happen. What if we, out of these 6 men, right, we want 3 men, 3 women. Out of the 6 men, take out the honorary man. So take out the man that refuses to serve with women. So just take him out. Now there's only 5 men from which to choose. So what we could do is we could choose now, out of the 5 men, choose any 3, but then out of the 8 women, we could choose any 3. So that could happen. Or what could happen is this. Well, out of this group here, instead of taking the honorary man out, we leave him in, but we take out the honorary woman. So just take her out of the mix. So now there's only 7 women left. So what we could do is out of the 6 men, we could choose any 3. But now out of the 7 women, we could choose any 3. Or, I think we could even do this. How about if we just take both of those honorary people out? Take out the woman, take out the man. In that case, there's 5 men to choose from, choose 3. There's 7 women to choose from, choose 3. All right, so when I computed that, I got 1610 if I computed it correctly. But I think the problem on the exam, on the sample exam, shows that answer to be 910. So something's wrong here. Let me just go back over it quickly. So 8 women, 6 men. Take the man out. So now there's 5 men, choose 3 of them. Out of the 8 women, you still can choose 3, right? We got 6 people. Now, what about here? Leave the man in, take the woman out. So there's 6 men, choose 3. You've taken the woman out, so now choose 3 out of those 7. And the last one, we'll take both of them out. So take out the man, there's 5 left, choose 3. Take out the woman, now there's 7, choose 3. And if I compute it correctly, I'm getting 1610.